guys and girls, welcome back to yyc-designz Custom RC Creations. I'm Twist. Today we're going to do a little bit of work on root beer. First of all, I got some new parts in and we're going to start there. So very groovy root beers differentials showed up. Let's open this puppy up and have a look and see what we got. Yeah, okay, so a little bit of a package from RC four-wheel drive here, and we got 1, 2 diffs. Let me get this stuff out of the way here. Okay, and we'll get on with this video. All right, so I ordered a couple of the, let's see if we can get this to focus here for you, the RC four-wheel drive Yoda 2 scale cast axle, front and rear. The rear one here is part number ZA0081, and of course the front is ZA0080. So let me open up the front one here, because there's some stuff I want to show you real quick. Okay, these are a very sexy little axle. They come packaged so well. I just love this RC four-wheel drive. RC four-wheel drive does an amazing job of packaging these axles and all. Okay, so these are the Yoda 2 axles that we are planning on putting into root beer. However, one thing you'll notice is that these are for a sprung truck. In other words, truck with springs. Now, root beer though is a 4-link. Okay, let's turn it around so front is front and back is back, left is right, left is left, and all of that jazz. Okay, so root beer though is going to be a 4-link, not a sprung suspension. Yeah, this is why I have this little piece of paper here, because as you notice now, this is where, right here, where your springs attach. Yeah, you get all your hardware, you got to buy those separate, and of course then you put your steering arm on so that everything functions and all of that. I'm not going to get into that today because we got to build that arm yet, which we will also be doing. I also bought her some of these links. Now these are part number, I'm trying to read it through the camera, which isn't working. These are part number Z-S1468. They're M4 high precision billet tie rod ends that we're going to be using on her. These are the nice little metal jobs, of course, ergo the word billet. And these are going to be her tie rod ends for the links I made in the last video. Okay, so those aside, because that's kind of the end of those for the moment. Okay, now what I'm going to have to do, and yes, I know you can buy this piece, I'm well aware you can buy it. What it is it's a little saddle that screws in, comes over, goes over the hump, and attaches down into the other saddle, and it gives you the little I will say components to bolt your links into. Now that piece, what is going to happen, my pen just exploded all over the place, so that one is now garbage, and I will move to using a felt pen instead here. Hopefully this one works. What we'll do is we have the differential, so I will make a piece that comes up and across and down, so okay, now it will bolt in the same way here into the differential, of course the pumpkin being here, and the spring mounts on the diff here. Yeah, a little hard to do this through a camera, but y'all are getting the idea of it anyhow. That's the main point. So what I'm going to do is I'm going to build this little saddle because I cannot see spending $30 Canadian plus shipping for a little chunk of metal that big. All I have to do is make the saddle, and on this saddle now, is obviously a front view. I'm going to give you a top view now, a top view down. Okay, so let's say this is the new saddle we made. There will be the bend so that it can have the bolt holes it requires. 2 more bolt holes to bolt into the other side. Now we're looking top down like this. Okay, so this piece here will bolt in so. Conversely, this one, this side. The center piece, of course, clears the pumpkin. But on this, what I have to do is add 2 pieces that will get welded on so, and that way when it happens, the links and the ends can be bolted through so. Okay, so that's what we're going to start with here today. Is we're going to start making this little saddle and this little piece. It might be a little hard to show you, but that's why I am explaining it this way rather than trying to explain it out in the big shop where we have not quite as good a light and all of that, and so that I can explain it to you. So in the end, all I will have to do is run 2 little 6 to 8 millimeter screws through this new saddle I make. So just before we continue on with the build here, I figured I would show you a visitor that just turned up outside of my door here tonight. And she's about 40 feet outside our front window, and I do apologize for the lighting. It's just after midnight now, and she decided to show up, so I didn't want to cast a bright light on her and spook her. And since we all love wildlife anyway, I figured I would show you our little visitor who loves to eat the apples off of our apple tree. And well, she's gorgeous, and we all love nature and our forests. Otherwise, why would we run crawlers and try to find nice trails to run on? So this is why we don't want to destroy our trails and take advantage like the guys with the big trucks have done. And sadly, we have lost a lot of our full-scale 4-wheel drive and off-road recreational trails here in Alberta. And it's because guys didn't take care of the trails, they didn't respect the forest, they didn't respect the wildlife. So this is why you're respecting our forests and wildlife. This happens to be a city deer, but we are only about maybe 10 miles away from the forest and woods called Fish Creek Park here, which leads into an area called Beaver Dam Flats, which leads right out to our beautiful, majestic Rocky Mountains here near Calgary, Alberta, Canada. We are very fortunate to have the beautiful Rockies so close to us. They literally are our backyard. So anyway, guys and girls, hope you appreciate a little bit of Mother Nature deciding to join us in our video today. Okay, so out in the big shop here. Now, I've decided that I am going to go with a 1/4-inch square steel rod that I think is going to look really nice on the RC 4-wheel drive axles. It's going to be a nice size and everything, and it should work out really well for the project. Now, the problem being is I'm going to have to find I guess I'm going to say I'm going to have to find a way to either use the square tube or fabricate my own out of sheet steel to make the 4-link mounts. So that's going to be the tricky part, and then tacking them on is no big deal. a little bit of heat, boom, should go pretty good. And then I've got a cool tactic for making them a really nice black, which I will show you all in time, whether it be on this video or a later video, I don't know. But anyway, we're going to continue on with making these saddles, and I'm going to show it to you here. Like I said in the teaser part or in the beginning of this video, I want to show y'all as much as I can, as close as I can, and that's one of the changes we want to try and make, is show more of our work. So let me get on with that, and we'll see what kind of video it makes, yeah? Okay, so getting ready to cut the supports here, as I said before, but in case you missed it, this is 1/4 inch solid square stock, and I'm cutting each piece at 4.5 inches. Like I said, you want to leave a little extra for the bending when I'm going to show you that here in just a few minutes. But you want to leave yourself a little extra. It's always good to have to trim off a bit than to not have enough. You can't grow it back, yeah? So careful measurements on this. And I am 3.5 inch spacing, so I left myself an extra inch just for fudge factor room. Out of 1/2 inch square stock, square tube stock that is, 1/8 inch thick wall, I am making 2 1/4 inch wide pieces. I'm cutting off one wall, effectively making a U out of the channels, or out of the tube steel, making it a U channel. Each piece is 1/4 inch wide. These will become the links for, or the link mounts for the 4-link suspension. These are little components that I mentioned that will get welded on to the saddle that we just finished making. Apologies, had a little hiccup there. Next, I'll be making the little feet that are going to attach onto the saddle via welding, and they will facilitate the mounting of the entire saddle unit onto the differential where the spring location holes are. I was just center punching them there. This is 1/8 inch steel. Each little piece is 3/4 of an inch long, 1/4 inch wide, and of course it's 1/8 inch thick mild steel out of a flat stock bar, just out of the scrap pile there. And no sense cutting into an expensive piece of steel. We just use some leftover scrap and drilling them out here. I am using a 5-meter drill bit, and we will attach them, of course, with the regular mount screws, and that'll attach the whole saddle to the differential, and we'll be off and running. Okay, so we have our axle, and now I've cut 2 pieces, as you can see, one front, one back. Now this is going to be a nice little fit along here. We're basically going to mark it where the bends have to be. So we've got to clear the yoke, or the pumpkin, and we have to clear the pumpkin. Now the other thing is, besides marking our metal, is we want to find out our angle. So if I take my diff, I'm going to use the straight line of the diff. Okay, now use the straight line of the diff, and I can basically see enough from where I am to figure out whether my angle will work. So I keep the straight line. There's my pumpkin. Now I realize I'm a little ways away here, but as I was saying, I can see here enough to tell whether my angle is similar or if I'm off. So I want that angle to be just a bit sharper, like so. I'm going to tighten down here. Now I know I have an angle of 47 48 degrees, okay? Right in between 47 and 48 degrees. So I'm gonna pick a 48 degree angle. So I want to make a little note of that. So I am 48 degrees on my either side of my pumpkin. So that 48 degrees is going to be right there, okay? Which will also be similar there. So just to prove to you that I'm not infallible either, and I do quite often make mistakes, I forgot to measure the center of my saddle that I want to make. I went and neglected to mark that. So I have a total distance here of 4 1/4 inches. So that will make it at 2 1/8 will be my center. And now I know I have a pumpkin that is 1 1/4 inches wide, so 5/8. And so at 5/8 I want to mark both of my saddles. 5/8 on the other side of center, I want the same mark. And there, so excuse me, so I have my saddles marked, this being my center, and 5/8 other side I have the mark, because of course that's where the bend is going to be to clear the pumpkin. Now the only other thing I have left to do here is to find out exactly how much I have to bend from the top of the pumpkin, of course, down to the original mount for the leaf springs, yeah? So what I can do is use one of my saddles and just take and hold it basically straight, okay? Give a measurement of the distance, which turns out to be a little under 1/2 inch. It's 1/2 inch will actually be close enough for a drop, so I can count on having about a 1/2 inch drop, okay? So that means at that bend I want to drop that down, and in 1/2 inch it'll straighten out, because I'll put another 48 degree bend in to go to cover the rest of the differential and reach the point we want to reach of the original mounts for the spring. Okay, so that is seriously one of my more favorite songs. Sorry about the bouncing around there. Okay, so now y'all are wondering what all these bits and pieces are for, yeah? So let's pull the diff a little closer into the situation and move you up and give y'all a look. Alrighty, so you seen me trimming the saddles. I have them exactly flush to where the shock mounts want to go, but as you notice, they are too narrow, no place to bolt, yeah? So that's why we go ahead and we made these little guys, okay? So these will get welded on here and put on each piece. We now have our finished link mounts, which will mount on beside them or up top here, whichever we decide. I am going to choose to put them up so on top of the saddle. That will give our vehicle more ground clearance. So one will go there and one there, and they will get welded on so, and these little plates will get welded on the bottom here. After I round them off, clean them up with the file and so on, I will spare you hand filing on 4 of these little dudes, but I just wanted to show you where we are so far. Yeah, alrighty, so that is the next step, cleaning these up, and we finally have our link conversion for a Yoda 2 sprung axle or sprung diff. Really guys, I don't know why the RC shops and guys in our community call that an axle. That is a differential. Axles are the pieces inside the differential. I don't know if it was the guys in China manufacturing them that misunderstood English terms and they marked them as axles, but that is a differential. An axle does not contain crown and pinion gears and all of the stuff that this differential contains. I wish people would use the proper terminology. It really pisses me off. I gotta tell you, it just pisses me off. End of my little rant. I wish they called them differentials. Okay, now, one thing before I forget about these saddles. If you're gonna make them at home, which some of you undoubtedly are, you have the equipment and tools and technology and all that at home. But if you've never made them before, or you've experienced a little issue with them before, I'm gonna tell you how to resolve it. Do not, when you make your curves with your torch or whatever heat source you're using, okay, I tend to forge these as well. I didn't on this one because the forge is being repaired. We will get into forging in a later video. Anyway, once you have made your curves and form them, do not dip them in water to cool them. This is mild steel. Mild steel reacts very, very well to dipping in cold water after heating it. It realigns the crystalline structure in the steel, and if you dip it in the water when it is around 1,000+ degrees Fahrenheit, which it will be to make these curves, the melting point of metal of mild steel is 1,700 degrees. So we haven't quite melted it, but we're awfully bloody close with how I've made it soft. We're reaching 1,500 degrees to be able to bend that like that, so nice and smooth. As you notice, it bent very well. I haven't got any little kinks on the side here. It didn't kink out badly. That is because of the heat I used. I take it up far enough that it is just below the melting point and the failure point, and then I bend it. If you were to dip that piece into water immediately after making that bend to cool it off so you could touch it, you've just made your first cardinal mistake, because you have now hardened that steel. Okay, that mild steel is now become like tooled steel. It is going to be a bitch to drill if you need to put holes into it. Yeah, I let them sit up there and cool all by their own lonesome until they're cool enough to touch by hand. Moving along, we're going to weld the foot onto the saddle. I like to set them down flat like this, give them a little tack just to hold each foot onto the saddle, and then I turn them upside down as you see me doing here, and I do the major portion, if I could talk, major portion of the welding from underneath. It hides it all, makes a much neater job in my opinion. And while I'm at it, yes, I could MIG them, but it's been my experience, I tend to burn the foot a little bit, or burn through it, and kind of messes up the job. So works much better for me to just use the oxyacetylene welding. And again, guys, girls, let these things air cool. Don't dip them, because any work you have to do on it, you're going to be doing it to tooled steel if you dip them. You want to keep that steel still nice and soft and ductile to work with, yeah? Last but not least, we're going to be welding on the link mounts. Again, as I said before, I chose to put them on the top of the saddle, and that way it gives a little more clearance to root beer, and I find it just makes a really nice looking little job to put them up top on these short little stubby pieces, because there isn't a whole lot of room in that lower leg to mount them anyway. So again, oxyacetylene welding, just because the MIG tends to burn through on the 1/2-inch tubing, especially right on the edges like that. You find it kind of burns a little notch out when you first strike the arc, and you got to fix it anyway. So yeah, you can fix it with a file, but it's just easier to not do it. And the oxyacetylene, I can flow the metal in, and it almost looks like it was cast or something instead of welded. Yeah. Anyway, a little bit of cleanup after all of this is done, and we have our saddle mount to convert from a sprung differential to a 4-link differential. Alrighty, so a little bit of an issue welding that last one, as you saw, but there we have it. Neither piece is cool enough right now to touch, and as I mentioned, you can't dip them in water now to cool them, because I still have to cross drill to be able to mount the links right. If I dip it in water, I'm going to harden the steel, and it's going to be a real bitch to drill them. So I leave them to cool on their own here in the vices. So here is the front saddle that we've created, and over here we have the back saddle. Now this one is super hot, so I'm not gonna get y'all too close to that. I'm gonna see if I can get you a little better lighting on it here so you can see it. There we go. I am working on a new camera rig to do have the camera mounted from the ceiling and the walls, and then we can start getting y'all some better shots and some more close-up stuff, because of course I can't zoom with this app that I use on my phone, but with the GoPro and with the new video camera we're getting, I should be able to get you some better shots of this small work and show you how I do it. But you can see clearly the holes drilled to mount into where it will attach on the Yoda axle, the Yoda 2 axle, I should say more properly. But you can see where it will mount there and how it will fit on the axle. And obviously the axle will be going this way so that it bolts in to the top of the saddle here. But like I said, this one's a little too hot to be getting that differential, pardon me. See, I'm in the habit now of calling the damn things axles, and it pisses me off. Anyway, that saddle is way too hot to be getting near that Yoda 2 diff. It's just, this is still sitting right around 500 degrees, and yeah, I don't want to be putting it by that brand new Yoda diff, that aluminum diff. So we'll go back to the one that is made for that diff. The one you just saw is made for the front diff. This is the rear. Originally made out of 1/4 bar stock, and then I took the 1/2-inch square tube, cut one side off, and formed the little U-joint pieces here, or little U's here, tacked them on. This mounting piece that mounts into the saddle is a 1/8 inch stock, 1/8 inch wide, originally an inch wide, all chopped down and dressed up to fit this application. Now the only thing I have to do, I'm going to try and get you a little bit of a shot here, is I want to take this angle, sorry about this guys, I want to take this angle here. Let's see, maybe I can do it differently this way. Get you a view of what I am talking about. Now you can kind of see how this is still square. I'm going to grind this off and angle it down so that it won't hang up on anything, because root beer is going to be a crawler. And so yeah, I'm gonna round. Maybe I can touch this and show you. I can now. Maybe I can get you a better look at this. So I am going to take the square edge off of this, and it will be nicely rounded and angled, is what I was trying to explain with all of that. So I'm going to get rid of the square edge on that. So we've got a little bit of filing to go and that sort of thing on these saddles yet, and then they will be ready. All in all, it's a good looking saddle. I think it probably wouldn't sell for 26 bucks US like the RC four-wheel drive one does, but it will do everything the RC four-wheel drive one does. And once it is powder coated, I think when y'all see it, y'all will agree with me that it is every bit as good looking as the piece they make to change a sprung Yoda 2 axle into a 4-link Yoda 2 axle. So that's gonna about do her for the root beer video. However, if y'all want to watch more of our content, which I hope you do, check out our Miss Voodoo series. Check out our London Calling and our Moose. They are amazing 16 scale tow trucks, wreckers, basically rotating wreckers at that. So there's a lot of technical stuff going on with these wreckers. Also check out, if you're into boats, we got some really cool boat builds going on right now, the Double Cabin Cruiser project and the Captain Goddard project. So a lot going on in the shop here, a lot for y'all to watch. I binge watch a lot of Old Iron RC. Not that I want to change you away from my channel, but Old Iron RC is an excellent channel to watch. And he has the cutest supervisor you'll ever see. Guaranteed. I'm not going to say any more about Kaomi. I hope I pronounced that name right, Mark. Kaomi. Anyway, she is just the cutest supervisor you'll ever see. Bar none. Maybe not. Tam might be almost, right? Now, she's my wife and all, but she won't kill me for saying that. You'll understand why when you see Mark's videos. Anyhow, guys and girls, that's going to do it for root beer. So yeah, there's a lot of other content to watch. So please like and subscribe if you enjoyed this video, and we will see you in the next video. I do apologize for the delay in getting this one out. I took ill for a couple 3 days there, so I didn't get out in the shop, which severely delayed this video getting out to y'all. But I am going to go into the little shop and start producing so I can get this out to y'all tonight, so you have some Saturday night viewing, and hopefully you'll watch our other content and just continue on binge watching yyc-designz, custom RC creations, and all our projects. Have a great rest of the weekend, guys and girls. Take care. Bye-bye.